Midwest Energy inaugurates its Giga Watt Scale manufacture facility for manufacturing battery energy storage systems. Integrated cell-to-container production strengthens India's advanced energy storage manufacturing capabilities. Bengaluru Vertical Bar, 20th July 2026. Midwest Energy, the technology and clean energy arm of the Midwest Business House, today announced the commencement of commercial production at its 1.2 GWh battery energy storage system (BESS) manufacturing facility in Bengaluru. The facility has been established with integrated cell-to-container manufacturing capabilities, enabling production of battery modules, trays, racks and fully integrated containerized systems to serve commercial, industrial, renewable energy and utility-scale applications. The commissioning of the facility marks an important milestone in Midwest Energy's journey in expansion of its capabilities at a time when battery storage is becoming an essential component of modern power infrastructure. As renewable energy deployment accelerates and grid flexibility becomes increasingly important, battery energy storage systems are expected to play a significant role in supporting reliable power supply, renewable integration, and energy resilience. Facility highlights: annual manufacturing capacity of 1.2 GWh. Integrated cell-to-container manufacturing. Wide capacity range from 3 kWh to 6 MWh, 48V1500V. Applications across commercial, industrial, renewable and utility sectors. Advanced quality assurance, traceability and end-of-line testing. Products aligned with UL 1973, UL 9540 and UL 9540A. Customized solutions. Soumya K., Chief Executive Officer, Midwest Energy Limited. India is pursuing an accelerated transition towards a cleaner energy future driven by renewability, sustainability, decarbonization and decentralization. The increasing Midwest Energy. MED Midwest. Integration of renewable energy into the power grid is fundamental to achieving these objectives. While it presents challenges such as demand-supply mismatch, grid instability, and supply uncertainties, battery energy storage systems (BESS) provide a reliable, effective, and fast deployable solution to address these challenges and enabling a resilient, stable, and decarbonized energy ecosystem. Through this facility, we are building indigenous capabilities to design, manufacture and deploy advanced energy storage solutions that are proudly designed and made in India. Our vision is to become a trusted long-term partner in supporting the country's clean energy transition. Midwest Energy will focus on supplying advanced battery energy storage systems across domestic and international markets while expanding its portfolio of customized energy storage solutions for diverse customer requirements.
What is important to note here is it is built with one small unit, like a Lego set, into set bigger and bigger and bigger and bigger. But it is not putting all the units, single unit, in one way. So it is made as a module. Then from module it is a rack. From rack it is a set of racks. From set of racks it is a container size product. So the whole energy storage system is what enables us to take all the renewable energy, which is not available all the 24 hours. It is available only for 4 to 5 hours peak in some sun cases. And in the case of wind, it fluctuates with seasons and during the day also. So if you take all of these sources of energies, then you need to have a bigger solar field, as it is called. Then you store so that during the off sun hours, you have energy to give. This is one. But just as we have a small button cell battery to a very large energy storage for different applications, we have to customize it for applications. So the customization will require a use case study and then appropriately do it. It can be something small at a 1 megawatt hour. We call the unit as 1 megawatt hour or a kilowatt hour or a watt hour. And see, your small battery in your cell phone or power bank is just 100 watt hours. Now this is gigawatt hours. So that means it is 10 power 9. 9 orders of magnitude higher is the storage. But imagine, that is what nature, sun is giving us. We are only taking 1% or fraction of a percent and we are trying to store it. Once this is...
I'm Soumya, I'm the CEO and director of the company. We have set up a 1.2 gigawatt plant with automation will scale up to 2 giga and the next 2 to 3 years up to 6 gigawatt. We do cater to renewable energy industries and then greening of regular factories and manufacturing plants, C&Is, and also the hospitals. Wherever you can use a DG set, you can think of a BESS to convert into green energy. That's the space where we are in.
How about EV batteries?
We can do EV also in this line, and we are in talks to a few of the big EV groups to make some battery packs for them. Same line can be used for EVs as well.
Basically support electrification and decarbonization of mobility as well as support renewable injection into the grid, that is in the form of solar, wind, tomorrow a small hydro, micro hydro. That's exactly what we are trying to do. Since what happens is when you are using from right now we are using mostly fossil fuels, either coal or gas or whatever we are doing. They are base loads, very easy to maintain. And whenever there is a demand, you increase the production, generation. But in the case of renewables, not in our control. When the wind is there, it will generate more. When the solar is there, sun is there, it will generate more. But we may need in the evening when both are very weak or it is not there. So this will balance. It will take the power when excess power is available and cater to the needs of the people when the demand goes up very high. That's how otherwise renewables will not be able to accommodate the needs of the people. It's just a beginning. It's only beginning. We are a technology company. We go on making improvements in terms of materials, the process, the product specifications and production systems, make them more and more reliable and also cheaper. That's what exactly we will do.
What's the capacity of this?
Capacity.
Current capacity is 1.2 gigawatt per annum, and will be going up to 6 in next 3 years, 6 gigawatts per annum.
Continuously increasing.
Yeah.
We'll also go for a backward integration. We don't make the cells now. We'll also make these cells in future in India.
Also, currently it's semi-automated. We'll go for completely automated plants.